Continuing on in Chapter 3, Parallel and Perpendicular Lines. And today we are going to be talking about Section 3.5, which is point slope formula and the point to line distance. All right, so we're going to start off with point slope formula. Now, the point slope formula is an equation of a line given a slope and a point, x sub 1, y sub 1. The formula is y minus y sub 1 equals the slope m times the quantity x minus x sub 1. Now, one key here that I just need to point out is when you look at these, notice how they are both a subtraction. So that means if, for example, it says something like this, if it says y minus 3 equals 2/3 times x plus 4, now, since this sign changed to a plus, then that means the x value had to be a negative that get plugged in there, because minusing a negative turns it back to a positive. This one is a minus, just like it's supposed to, so it would stay as the positive point, 3, and then my slope would be 2/3. Okay, so that's how you read through that. So you have to be very careful of the signs on this one. On this formula, that is probably the trickiest part, is just paying close attention to those positive and negatives in front of the y sub 1 and the x sub 1. All right, so what we're going to do is we're going to use this formula to write the equation of a line in slope-intercept form that passes through the point 1, -2, and is parallel to the original line of 3/4 x plus 2. Okay, so the first thing we need to do is we have to know our slope of our parallel. So I look over here, and the slope of my original line is 3/4. So then the slope of the parallel, remember that relationship has to be the same. So now I'm going to take my point, 1, -2, and the slope of the parallel, 3/4, and I'm going to plug them into the point slope formula. So I'm going to go y minus, if you want, you can write it minus a -2, equals the slope, 3/4, times x minus the x value, which is 1. Now, let's just clean this up. So the first thing we're going to do is this is going to turn into y plus 2 equals 3/4 x. I'm going to distribute that in, minus 3/4. Now, I want it in slope-intercept. So what that means is I have to get rid of that 2. Because remember, slope-intercept form has a y equals only. So I'm going to subtract the 2 from both sides. So that's going to leave me y equals 3/4 x. Then over here, I'm going to take a -3/4, and I'm going to minus 2/1. Remember, we have to find a common denominator. And so that's going to give me a -8/4 and a -3/4, which is going to give me a -11/4. Okay? And that would be the equation of the line that is parallel to the original line that passes through that point. Okay, let's try another one. So again, we read through, here's my point. I want it parallel to this line. So the first thing I have to do is I have to take this original equation and I need to find the slope. So I'm going to minus the 16x. Then I'm going to divide by 4 to everything. So my original slope is a -4. Now I look, I want the parallel. Remember, the parallel slope is the exact same. So I take the new point and my slope now, and I plug them in. So this is going to go y minus the y value from my point, which is 6, equals the slope, -4, times x, minus the -3, which is going to turn that to a +3. At this now, we're going to distribute. So I have y minus 6 equals -4x minus 12. I'm going to add my 6 to both sides, and that's going to end up y equals negative 4x minus 6. And that is the equation in slope-intercept form that passes through that point and is parallel to the original equation. Okay, let's try another one here. So on this one, equation of a line in slope-intercept form that passes through this point. This time we're going to do perpendicular to the original equation. So my original equation slope is 3/4. So now I'm going to find the slope of the perpendicular. Remember, the relationship is we change the sign, so it was positive, I'm going to make it negative, and then I take the reciprocal of that fraction. So now that's negative 4/3. I'm going to take that with my point, and I'm going to plug it in. So I'm going to go y minus a negative 2, which is going to turn it to plus 2, equals negative 4/3 times x minus a negative 4, which is going to turn it to a plus 4. At that now, we're going to distribute. So that's going to give us y plus 2 equals negative 4/3 x minus 16/3. I need to get rid of the 2, so I'm going to minus 2 from both sides. So I'm going to be left with y equals negative 4/3 x. This as a third would be negative 6/3. So negative 16 minus 6 more would get me negative 22/3. We cannot simplify that in any way, and that would be the equation of the line perpendicular to the original that passes through the point negative 4, negative 2. All right, let's try one more here. So again, I have my point 1, 3. I'm going to go perpendicular through this original equation. So to start with, I need to find that original slope. So I'm going to go 5x plus 2y equals 14. I'm going to minus the 5x. And then I am going to divide everything by 2. So it would be negative 5/2 x plus 7. The slope of my original line is negative 5/2. The slope of the perpendicular then, remember we switched the sign. It was negative. I'm going to make it positive now. And then I reciprocate it. So now it's going to be 2/5. I flip it, the fraction. So I take the point and my new slope and I plug it in. So y minus 3 equals 2/5 times the quantity x minus 1. We're going to distribute the 2/5. So y minus 3 equals 2/5 x minus 2/5. At that now, I'm going to add 3 to both sides. So I'm going to be y equals 2/5 x. This would be 15/5. So negative 2/5 plus 15/5 is a positive 13/5. And that would be our line that is perpendicular to the original line passing through the point 1, 3. All right. So now what we're going to do is we're going to look at finding the distance between a point and a line. Okay. Now, when we look for this, what we're asking is the length of the shortest possible segment with endpoints that are on the given line and a given point. The shortest segment will always be perpendicular to that line. Okay, this is important. We're going to look for the perpendicular to that line in order to find the point on that line that we are going to use. All right, so here we go. Let's take a look at this. We want to find the distance. So the first thing I'm going to do is I'm going to graph my line. My line has a slope of 3, a y-intercept of 0. So I'm going to start here at 0. Remember, 3 is really like saying 3 over 1. So I'm going to go 1, 2, 3 over 1, 1, 2, 3 over 1. Okay, so now I'm going to take that. I'm going to draw my line in. And we're going to keep that as straight as we can going through all of those. My point is at negative 4, 8. 1, 2, 3, 4. So here's my point. Now, here's what we know. remember I said the shortest distance between the point and the line would be the perpendicular of that. So when I look over here, the slope of the perpendicular to that original line would be a negative 1/3. We switch the sign and we flip it. So what I'm going to do is from my point, I'm going to come down 1, right 3. I'm going to come down 1, 1, 2, 3. So the perpendicular is going to be right on that line there. Let me make that just a little bit straighter here. Okay? So what I want to know now, you'll see I'm crossing this point and I started here. So I want to know that distance. So that distance is from -4, 8, and my other distance is at, or my other point is at 2, 6. So now we do the distance formula. Remember, the distance formula is we go x minus x, so I'm going to go -4 minus 2 squared plus y minus y squared. So -4 minus 2, that's a -6 squared. That's going to give me 36. 8 minus 6 is 2. 2 squared is 4. So that is going to give me the square root of 40. We simplify that. Remember, square root of 40 has two numbers. One's a perfect square, 4 times 10. So that's going to give me an exact of 2 square root of 10. And then we take that and we're just going to simply punch that into our calculator. So we're going to go 2 second square root of 10. And that gives us 6.32. So we're just going to round to the tenths, so 6.3 units. And that's how we find that. Okay, let's try another one. So here we go. We're going to start off with what we know. So the first thing I'm going to do is I'm going to graph it. I have a slope of 1 and a y-intercept of -6. So I start down here at -6. From there, I'm going to go up 1, right 1, up 1, right 1. I connect that up. There's our original line. The next thing I'm going to do is I'm going to plot my point. So I'm at 1, 9. Okay. Now, here's what I'm already kind of noticing. I'm wondering if I drew my original line long enough. So what I'm going to do is I'm just going to keep following it all the way out here. Okay. See if we can connect it to the right thing. So now I want the perpendicular, remember? So the slope of the perpendicular would be a -1. So I'm going to go down 1, right 1, 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 down 1, right 1. So now I'm going to use this point and this point to find the distance between those two. So now I'm going to take those 2 points. So I have 1, 9 and 8, 2. So now I'm going to take those and I'm going to plug them into our distance formula. So I'm going to go, let's go 8 minus 1 this time. So 8 minus 1 squared plus 2 minus 9 squared. So the distance is going to equal 8 minus 1 is 7. 7 squared is 49. Plus 2 minus 9 is -7. -7 quantity squared is 49, which gives me the square root of 98. Now, that has a perfect square in it of 49 times 2. So that's going to give me an exact of 7 square root of 2. Then I simply take that, punch that in, second. 7 second square root of 2. And that's going to give me 9.89. So I'm going to round that up to 9.9 units. So that's going to use a lot of the math that we've already talked about this year. It's talking about our parallel perpendicular. It's talking about our distance formula, our slope, our y-intercept. So there's a lot of pieces there that you have to watch very closely to make sure you understand. But that's how we graph and write equations of parallel and perpendicular lines.